And on 651, we have our last question from section 7.5, and they are called pi over 12 questions. If you think about your unit circle, maybe it's been bothering you all this time that the spacing wasn't quite perfect, right? There's 30 degrees, and then there's only 15 degrees, then 30 degrees. There seems to be an angle missing, right? And if this has been bothering you, like you just can't sleep at night, I'm like, oh, it seems like we should be able to figure out that value in between. This has probably happened every night since you started the unit circle. I can just imagine that. Well, today's your lucky day. We figure out these angles in between without our calculator. And all of these angles in between are all pi over 12 angles, or angles like 15 degrees, 75 degrees. So we're going to find out, if I wanted to find sine, cos, tan of a pi over 12 question, this is our example 5, either in radians or degrees, how do I do that? And the key to it will be using our unit circle that we already know and using our sum and difference identities. So I'll give you a little bit of time to write down the strategy, and then we'll see what that strategy means. So you're going to use your pi over 3, pi over 4, and pi over 6 families, and either add them or subtract them to get the pi over 12 that you want to find. The reason you can do that is because pi over 3, pi over 4, and pi over 6 can all be written as a fraction over 12. And we're going to start off just by using the first quadrant, but you're allowed to use any pi over 3, pi over 4, pi over 6 family that's coterminal first time around the circle or even beyond. So if I wanted to find pi over 12, can you see how you could use 4 pi over 12, 3 pi over 12, and 2 pi over 12, how you could add or subtract a pair of those to get pi over 12? Can you see that you could do 4 pi over 12 minus 3 pi over 12? That would give you pi over 12. Or you could do 3 pi over 12 minus 2 pi over 12. That would also get you pi over 12. And we're going to find out that to solve these pi over 12 questions, we are going to have more than one option. And it doesn't matter which option you choose, it's going to work out to be the same. So if I want to find out cos of pi over 12, well, cos of pi over 12 is the same as cos of 4 pi over 12 minus 3 pi over 12. And the reason those values are nice is I can simplify them and say, well, that's just pi over 3 minus pi over 4. And now I have a sum and difference formula. I have a cos alpha minus beta formula. And what's different from the example that we did before is now you know alpha and you know beta. So when you substitute this into the right-hand side of the formula, yes, you get cos cos plus sine sine. A lot of things. It seems like you're not really making this any more simple, but each of those are values you already know on your pi plate. And so when I go to cos of pi over 3, well, I know that that's a half. And cos of pi over 4, that's root 2 over 2. Sine of pi over 3 is root 3 over 2, and sine of pi over 4 is root 2 over 2. We need to write our final answer as a single fraction. If you multiply the tops of your fractions and the bottom, you'll see you'll have a common denominator of 4. Adding the tops, root 2 plus root 6, all over 4. Now, if you run out of space on page 651, there is a little bit of space on page 650 as well. We have another 3 examples, so this you might have to find some more space too if you're writing really big. So here's part B. Part B was in degrees. Now above that there, I just converted 75 degrees to radians. 75 degrees is 5 pi over 12, so it is a pi over 12 question. But if it's in degrees, we have to do the same strategy, just in degrees. You ask ourselves, are there 2 values on your pie plate that add up to 75? Well, 30 and 45. And so now we have a sine alpha plus beta. So we go to our formula sheet and say, what is our sine alpha plus beta formula? It's sine alpha cos beta plus cos alpha sine beta. Each of those values is on your unit circle. So I'd like you to go from here and finish it up. I'll put the answer up in a second. All right, see how you did. Were you able to get root 6 plus root 2 all over 4? Just coincidence that it is exactly the same as the one before, but not coincidence in that you see a root 2, a root 6, and a 4. For sine and cos of all the pi over 12, you will always have a root 6, always have a root 2, and it'll always be over 4. What's going to change is sometimes the root 6 will be negative. Sometimes the root 2 will be negative. Sometimes both will be negative. So that's the part that can change here and there. For tan, it's not going to be root 6 plus root 2 over 4. But for sine and cos, it will always be. Now, before we do our next one, and our next one is a larger value of pi over 12, 17 pi over 12. What we're going to do as an activity, and I'll give you a scrap paper for this so you can try, is each one of you have to come up with 2 things that add or subtract to make 17 pi over 12. Okay? But as soon as you find one, you call me over because I'll put it up on the board. And once that one's been used, that means nobody else can find that one. They have to find a different one. So then you're kind of wanting to try and find one as fast as possible so you get one to put up there. So that, because if you find it and you're like, oh, someone already found that one, then you have to find a different one. And if you've already found one, your job is to try and make it as most difficult for your classmates as possible, right? We want to start a war. And find another one so you take that away. There's an infinite amount of them. So we shouldn't run out of right answers. But there are some that are easier to find than others. So I'll give you some scrap paper. You have to find 2 ones from your pie plate that add or subtract to be 17 pi over 12. Here are the results of 7 of them that we found. What kind of pattern do you notice between all 7 results? Do they have anything in common? Okay, so what's in common then? They always have 1 pi over 4. So if we look at the first one, this one has a pi over 4, this one has a pi over 4, this one has a pi over 4, this one has a pi over 4. I mean, we knew that we had to use pi over 4, pi over 3, and pi over 6 families, but in looking at all 7 of these, we always had a pi over 4 family. Now, the reason for this is anytime you're finding a pi over 12 family member, does it make sense that this number has to be odd? If it's an even number, you could simplify it and it would no longer be a pi over 12 question. It would be a pi over 6 question. Or maybe it would simplify even further. So that number's always going to be odd. And if we would go back to our notes and the first thing that I wrote, when I wrote out pi over 3, pi over 4, and pi over 6, in red, I wrote out that when it was over 12, 2 of them are even, and only the pi over 4 one is odd. And if you're adding and subtracting two numbers and you want to get an odd number, the only way to do that is to do even plus odd or even minus odd. If you have two even numbers, you always get an even number. If you have two odd numbers, you always get an odd number. So we're always going to need a pi over 4 family member. So if I would pick another random 23 pi over 12, another random pi over 12 question, and you were asked to find two things, because on a test, you don't want to spend 10 minutes trying to find the two that work. You want a system to be able to find that quickly. And the system is you need to use a pi over 4. And it doesn't matter. Any pi over 4 will work. So pick a random pi over 4 family from your unit circle. 5 pi over 4. If we started with 5 pi over 4, you know that 5 pi over 4 is what over 12? Well, I'd multiply each of them by 3. I'd have 15 pi over 12. So I want to get 23 pi over 12, and I start with 15 pi over 12. I ask myself, well, what would I need to add to that to make 23? 8. And as soon as I reduce this, sure enough, this is 5 pi over 4, and the second one will always reduce to something on your unit circle. So it doesn't matter which pi over 4 you start with, it'll always work out that the other one will match up. So in each of these, you could just, like, if we say, well, what's a pi over 4 we haven't done yet? We've got pi over 4, 3 pi over 4, 5. You've got the whole first quadrant. You got negative pi over 4. You got 9 pi over 4. What's another pi over 4 family we could use? You want to do something with 11 pi over 4? So if I did 11 pi over 4, right, and underneath here, I'm going to change that to 33 pi over 12. If I wanted to get 17, I'd have to subtract 16 pi over 12. And so here I'm going to subtract, and 16 pi over 12 simplifies to 4 pi over 3. And sure enough, there's another one. Now, you won't be going and doing super high ones like the one that I put up, the 101 pi over 4. That's a little bit ridiculous, okay? But you will be using ones in your first time around the circle. So when we go to solve the question that we were just on, we can choose any one of them to figure it out. So I happen to choose here in the notes, right? I chose 21 pi over 12 as my starting one. I started with 7 pi over 4. And I started with 7 pi over 4 because it was really close to 17. Maybe you would like to start with 5 pi over 4 because it's even closer to 17. But it doesn't matter. Now, if I chose 21 pi over 12, I need to subtract 4 pi over 12 to make 17. I reduce those, and they're both on my pi plate. So my alpha is 7 pi over 4. My beta is pi over 3. And now I'll give you a second to expand this, write it out. Your final answer, like I said before, should have a root 6, should have a root 2, and a 4. And I'll show you the answer in a second. So check how you did. Cos, cos plus sine, sine. Go to your unit circle. And in this case, the root 6 is negative. It's root 2 minus root 6 all over 4. Because 7 pi over 4 is in quadrant 4, you have to be careful because sine in quadrant 4 is negative. So we get negative root 2 over 2. Cos of 7 pi over 4 is still positive because cos is positive in quadrant 4. Now, sometimes in these questions on the final exam, they have a part B. And the part B, if part A was find cos of 17 pi over 12, part B says find secant of 17 pi over 12. Well, if you've done all this work and found cos of 17 pi over 12 is root 2 minus root 6 over 4, then cosecant, or secant, sorry, of 17 pi over 12 will just be the reciprocal, and all you have to do is flip the fraction. And the reason they put this as a part B is they used to ask it just as a question, what's secant of 17 pi over 12? And if the student didn't think to do cos of 17 pi over 12 first and flip the answer, they were getting 0 out of 4. So too many students were getting 0 out of 4, and they thought, okay, how can we ask this so that you don't lose as many marks? We'll ask cos first, and then in part B we'll ask secant. And as long as you flip whatever answer you got in part A, even if your answer was wrong in part A, if you know that secant is a reciprocal and flipped your wrong answer, you'd still get full points. Hardest question that's been on an, well, not hard, but just a little bit different. This was a question on an exam a while back. It's cos of 11 pi over 12. That part's exactly the same, but there's a 4 in front, which just means 4 times cos of 11 pi over 12. So all we have to do is solve cos of 11 pi over 12 like normal. Whatever answer you get, multiply it by 4. So I'm going to get you to try this one on your own, and out of the textbook, it's number 7 to do for practice. Once you get your answer, call me over and I'll check if it's right.